Whether we call them word problems in algebra or call them real applications of algebra, some people call them simply impossible. But that's not true. If you can remember the alphabet, you can remember how to approach and overcome a word problem in algebra. It's as simple as PQRST. We preview, we identify the question, we rewrite or translate, solve, and then test the solution. So, let's try one of those impossible word problems. Two consecutive integers which add up to 35. Let's see. PQRST. You have to know what the problem says, know what you're looking for, translate the English words into an equation, the language of algebra, solve the equation, and check your answer. PQRST is just a way of helping you to remember that. Let's take it step by step. P for preview, read the whole problem. Understand what it says, see if there are any words you don't understand. How about the word integer? An integer means a whole number, like 1 or 2, 15, 63, not a fraction or a decimal. And what about two consecutive integers? That's just two whole numbers in a row, like 3, 4, or 7, 8. Next step, Q for question. What are you looking for? And can we name it with a letter? Usually we can, and that's important because we need a way to represent our unknown, we call it the variable, to make an equation. Since our word problem asks for consecutive integers here, we can name one integer x, and the other, since they're consecutive, has to be x plus 1. Step 3, R, rewrite. That is, translate the word problem into the language of algebra. We write an equation. Two consecutive whole numbers which add up to 35. This is just a plain old linear equation, and you know how to solve linear equations. Let's work through it. First, you combine like terms. Then, subtract 1 from both sides to get the 2x by itself. Then divide both sides by 2 to get from 2x down to a simple x. And there's your solution. Or is it? We solved for x, but we have not quite answered our original question. At this point, you'll always want to go back and ask yourself, what was the original question exactly? In this case, we wanted two whole numbers. We named one x and the other x plus 1. So if x is 17, then the other number must be 18. We'll find out if this is correct in the final step, T for test, where you check your answer to make sure it works. The answer works because we followed our alphabet, PQRST. Preview, question, rewrite, solve, and test. Ready to handle one by yourself? Try this word problem. Here's a hint. Notice that we're talking now about even integers. Think about how far apart even integers have to be. Pause the program now, give it a try, and when you're ready, click play, and we will compare solutions. We tackle this word problem using our alphabet, P, Q, R, S, T. Preview. Two numbers added equals a multiple of a third number. The problem is easy enough to understand, and I understand consecutive, even, and integer. So I move on to notice exactly what is asked. The question. Find three numbers. Let's call the smallest one x. They're even numbers, so the next one will be larger by 2, like 8, 10, 12, or 14. So we call the second one x plus 2. The largest of the three is x plus 4. Can we rewrite it into an equation? We can. The largest plus the smallest equals 6 times the middle. Once we've expressed our problem as an equation, it's no big job to find the right answer step by step. Add like terms on the left. Apply the distributive law to the right. Simplify by subtracting 4 from both sides and subtracting 6x from both sides. And then we get down to a simple x by dividing both sides by -4, which tells us that x equals -2. Is that the answer? No, it's the beginning of the answer, because the question was find 3 consecutive even integers. X, or -2, is the first one, x plus 2, or 0, is the second, and x plus 4, or +2, is the third. Are they the correct 3 consecutive integers? We can easily test to see if they fit the story. -2 plus 2 equals 0, and 6 times 0 is 0. 0 equals 0. Our solution works. Word problems may seem impossible, but they can be solved if we get them translated into the right equation. Try another one. Look impossible? Don't panic. First, do you understand all the words here? Good. Preview done. Let's jump straight to the question. Find Sarah's age. First, we need to name the variable, but it presents me with a little problem because there are 2 rules I like to follow in naming a variable, and in this case the 2 rules disagree. Rule 1. Use x for the quantity you are trying to find. That would be Sarah's age in this case. Rule 2. Where you have several unknowns, use x for the smallest one, and that would be Jenny's age. Here I'm going to opt for the second rule. You will see later why it works better this way. We will call Jenny's age x, so Sarah's age is 2x. And we'll have to remember that when we get our answer for x. Now let's translate the word problem to algebra. Since Jenny's age, x, plus Sarah's age, 2x, equals 69, we have our equation and we're ready to go to work. We see that 3x is 69. Then 1x is 69 divided by 3, or 23. And we have an answer. Well, almost an answer. Remember, I decided to let Jenny's age be x. So Jenny's age is 23. But our question was, find Sarah's age. Sarah is twice as old as Jenny. So Sarah is 46. And that's our real answer. We test our answer by adding our values for x and 2x, 23 and 46. The sum is 69, and our answer checks out. Now, why didn't I use Sarah's age as x in this problem? After all, it is what we were looking for. The answer is, I like to avoid fractions in my equations whenever I can. By taking the smallest unknown, Jenny's age, as x, we get this simple equation. But if I took Sarah's age as x, then Jenny's age would be half as much, or 1/2 x, and my equation would have a fraction in it. Would this equation work? Yes, it does translate the word problem correctly, and it would give you Sarah's age directly as your answer. But it would take you a little longer to get there because of that fraction. Follow along as I show you the extra steps involved. And don't forget, when you get your answer, to go back and ask yourself, what was the question, and what was x? The question was, what is Sarah's age? And this time we let Sarah's age be x, so we have our answer directly. You'll find more examples of word problems like these in your textbook. Here's a problem for some immediate practice. Don't let the words scare you. Look for the question. Do it the same way we did the last problem. Pause the program until you have an answer, click play, and we'll compare notes on how we handled this word problem. I will assume we all understand about rent and utilities, so let's skip the preview and see what the question is. Notice that the question is frequently written as a statement, but the meaning is a question. What is your monthly utility bill? And in this case, I have no trouble deciding what to call x. The most important unknown is the utility bill. The smallest unknown is the utility bill. So what will x be? You're way ahead of me. The utility bill. Now I need to write a term for the rent. Rent is 10 times the utility bill, so I use 10 times x. And in the rewrite or translation step, I turn all of it into an equation, a simple equation that won't take long at all to solve. Just remember to use division to get rid of the 11 to get a value of 95 for x. Are we done? Or is there something you should be asking yourself at this point? You have x. Is it the answer? Well, what was the question? And what was x? The question was, what is your monthly utility bill? What do we write as x? That same utility bill. So your final answer is 95. Check your answer by substituting 95 for x in the equation. And it works. Notice that we could have done the problem the same way even if we'd been asked, what is the rent, instead of what is the utility bill. We just add a final step because the rent is 10 times the utility bill, or $950. And that's just one more reminder to ask, what was I looking for in the first place? And what was it that I named x? By now, PQRST and the exact meaning of each letter should be as familiar to you as the name of your best friend. If not, study them well. Write them down, think about them, and use them. Every problem is different, but these steps will save you lots of trouble. Be sure to try some practice problems from your textbook. How many problems? As many as it takes to be a PQRST wizard.